In this video, we're going to focus on the derivatives of inverse trigonometric functions. Here are the formulas. First, we have the inverse of sine function, or what we call the arcsine. So what we have here is arcsine of u, where u can be any function of x. Okay, differentiating arcsine of u with respect to x will result to 1 over the square root of 1 minus u squared du dx. Arc cosine is just the negative of the derivative of arcsine. So negative 1 over square root of 1 minus u squared du dx. Next, we have arctangent of u. Its derivative with respect to x is equal to 1 over 1 plus u squared times du dx. And then arc cotangent is just negative of the derivative of arctangent. So negative 1 over 1 plus u squared du dx. Next, we have arcsecant of u. Its derivative with respect to x is equal to 1 over the absolute value of u times the square root of u squared minus 1 times du dx. And the derivative of the inverse of the cofunction of secant, which is arcsecant, is negative the derivative of arcsecant. So negative 1 over the absolute value of u times square root of u squared minus 1 du dx. The absolute value in the formulas has something to do with the domain of the secant and cosecant functions. Okay, this just means that u is restricted to positive values only. Alright, so we have 6 formulas. You can just memorize arcsine, arctangent, and then arcsecant, and then just put negative sign to the derivative of the co-functions, right? Okay, so let's solve some examples. First one, we have find dy dx if y is equal to arcsine of 2x. So we have y equals arcsine of 2x. Recall that the derivative of arcsine, so arcsine of any argument where u is any function of x, right, is equal to 1 over the square root of 1 minus u squared du dx. Okay, so taking the derivative of the given function with respect to x will result to this expression here on the right side. So we have here 1 over the square root of 1 minus u in this case is 2x, right? For this example, u is 2x. So we have the quantity of 2x squared. 2 here, this factor is the derivative of u with respect to x. Since u is 2x, then taking the derivative of 2x with respect to x will get 2. Okay. So just simplify, you get 2 over 1 or square root of 1 minus 4x squared. We can consider this as the final answer, so we can stop here. Or if it is required, then we have to rationalize. Okay. And then if you are required to express your answers in factored form, then we have to factor. Okay. Next problem. We are asked to find dy dx if y equals arctangent of 4 over x. So recall that the derivative of arctangent of u, where u is any function of x, is equal to 1 over 1 plus u squared du dx. Okay. So if we differentiate the given function arctangent of 4 over x with respect to x, it would result to this equation. So dy dx equals 1 over 1 plus the quantity 4 over x raised to 2 times negative 4 over x squared. So the first part here, so this portion of the derivative represents this part of the equation of the general formula, right? So 1 over 1 plus u squared. In this case, u is 4 over x. Okay. And then next, this portion of the derivative is the result of taking the derivative of u with respect to x. So again, u is 4 over x. So if we differentiate 4 over x with respect to x, so we have a fraction, apply quotient rule, low d high. So copy the denominator, differentiate the numerator with respect to x. 4 is a constant, so its derivative is 0 minus high d low. So copy the numerator, differentiate the denominator with respect to x. So x with respect to x, that would be 1 divided by low squared, so x squared. And simplify, we get this is 0, so negative 4 over x squared. And this is equivalent to negative 1 over 1 plus. So we have 4 over x raised to 2. We get 16 over x squared, right? Times 4 over x squared. And then apply LCD in the denominator so that we can express the two terms into a single fraction. Okay? And so we get negative 1 over the quantity x squared plus 16 all over x squared. Okay? And then since we have a denominator, in the denominator, this is equivalent to negative x squared over x squared plus 16 times 4 over x squared. We can now clearly see that we can cancel out x squared. Okay? And so final answer is negative 4 over x squared plus 16. Problem number 3. Find dy dx if y equals arccos² square root of 4x plus 1. So given now derivative of arccos² of u, where u is any function of x, is equal to negative 1 over absolute value of u times the square root of u squared minus 1 du dx, right? And so the derivative with respect to x of arccos² square root of 4x plus 1 is negative 1 over absolute value of square root of 4x plus 1 times the uh, square root of 4x plus 1 raised to 2 minus 1 times 1 half 4x plus 1 raised to negative 1 half times 4. The first part here of the formula of the derivative represents this part of the formula, right? So negative and then 1 divided by absolute value of u. U in this case is square root of 4x plus 1, right? So absolute value of 4x, square root of 4x plus 1, then times the square root of u squared. Again, u is square root of 4x plus 1, and then minus 1, okay? And then this part of the derivative is your du dx, okay? So again, u is square root of 4x plus 1. To find the derivative of radicals in general, we can express them in exponentials, right? With fractional exponents, okay? And so we can apply the general power rule. So we have here a radical of index 2. This is square root, right? If we convert this to an exponential, then it is written as quantity 4x plus 1 raised to 1 half, okay? So u raised to n apply general power rule. And then let's simplify. We'll get negative 1 over absolute value of square root of 4x plus 1. And then inside this radical, this cancels out, right? So the result is just 4x plus 1 and then minus 1, okay? And then here we can divide 4 by 2. So we get 2. And then convert this negative exponent to a positive exponent. So we have to transfer this to the denominator. Okay, and express it as a radical. So 2 divided by square root of 4x plus 1. And then we can combine these two, square root of 4x plus 1, square root of 4x plus 1. So we get 4x plus 1, right? 1 half plus 1 half is equal to 1. So this is raised to 1, okay? And then here, plus 1 minus 1, so cancel out. So that we are left with square root of 4x, okay? And then 2 in the numerator. So 1 times 2, that's 2. Now evaluate square root of 4, that's 2, right? So we can cancel out 2. And then rationalize. We can write the final answer as negative square root of x over x times quantity 4x plus 1. Next problem, find dy dx if y equals x times arccosecant squared of x. Okay, so we have two factors here, x and arccosecant squared of x. Okay, so we have to apply the product rule. Now, arc cosine squared of x is the same as quantity arc cosine of x squared. Okay, so we have to apply general power rule to get the derivative of arc cosine squared of x. Taking the derivative with respect to x will result to this equation. We have two terms, again because of the product rule. Okay, so first term, just copy x and then differentiate arc cosine squared of x with respect to x. Okay, so again, arc cosine squared of x is the same as the square of arc cosine of x. So apply general power rule. Bring down 2. That's why we have 2 here. And then just copy arc cosine, right? So recall product rule. We have n u n minus 1 du dx. Okay, so n in this case is 2. So 2 here. And then u raised to n minus 1. So arc cosine x 2 minus 1. That's why we get arc cosine of x raised to 1. Okay, and then du dx. So arc cosine is negative 1 over square root of 1 minus u squared. U in this case is x for the derivative of inverse cosine. Okay, and then du dx, where u is x, so derivative of x with respect to x, this is multiplied by 1. Okay, and then second term for the product rule, just copy arc cosine squared of x, right? So we have here arc cosine squared of x. And then take the derivative of x with respect to x. So that's equal to 1. So 1 times arc cosine squared of x. Simplifying, we'll get negative 2x arc cosine of x over the square root of 1 minus x squared plus arc cosine squared of x. We can rearrange the two terms. Let's write the positive term first. So we have arc cosine squared of x minus 2x arc cosine of x over 1 minus x squared. Again, if you are required to express your answer in factored form, then you factor out arc cosine of x. Okay, but we can consider this our final answer.